Ooh, how's it going, guys? Hey, Davis here. Another day, another problem in LeetCode. I was looking at his solution because his solution is a bit different than mine. But we're gonna go over my solution. We're not doing binary trees today. I just felt like mixing it up. We're doing reverse integer. This problem seemed fairly easy, and it is. It's just a few cases you gotta check out for. So given a signed 32-bit integer x, return x with its digits reversed. If reversing x causes the value to go outside the signed 32-bit integer range, negative 2 to the 31st squared and 2 to the 31st squared minus 1, then return 0. Assume the environment does not allow you to store 64-bit integers, signed or unsigned. So we're just giving 3 examples. One's 1, 2, 3, you reverse it. One's the negative 1, 2, 3, you reverse it. And then given 1, 2, 0, you just want to return 21. So this problem seemed pretty easy. It didn't seem too hard, but I did have a little bit of trouble with it, just because there's a few things I didn't look out for. The first thing I did was we need to realize if the value is negative, right? So I kept it as negative value, and that is equal to x. If x is less than 0, then it's negative, right? And so at the end, we'll do something like return, I called it solution. Return solution, well, we'll return is neg. We're going to use the ternary operator, so is negative. And then if it is negative, we'll return solution times -1. And then if it's false, we'll just return solution. Okay. The next thing we want to do is, well, the logic for this is I kind of want to store. I created a queue so we could get the values and then reverse the values, right? So we're going to do a queue of integers. Call this, I just called it num queue. And this is going to be equal to link to the list integers. And then from here, we want to be sure to do a few things. So we want to do this while x does not equal 0. And then if x equals 0, we want to do num q. We want to store the first digit, right? So let me pull out the epic pen so I can draw this out for y'all. So we're going to use the mod operator and the divide operator, and we're going to divide it and mod it by 10. So if you take any number given 1, 2, 3, and if you do the mod of it, you will mod by 10, you will get the value 3. So if you mod any number by 10, it will give you the first digit's place. And then do an integer division as well. If we divide this number by 10, it will give us just 12 because it truncates the 3. And if we do that all the way down, we'll get 2 for the next mod. It's kind of hard to draw right now. And then the next division by 10, we'll get the value 1, and then mod it one more time, divide it one more time, then we'll get 1 and 0. And then when it equals 0, we'll break out. So we want to store the mod operator inside of our queue. And the way a queue works, it's first in, first out, right? So we'll put the 3 in the queue, and then we'll put the 2 in the queue, and then we'll put the 1 in the queue. And then when we pull it out, we'll pull out the 3, the 2, and then the 1 to build our integer back up. Now the solution I was looking at uses string builder. I don't know too much about string builder. All I know about string builder is Java strings are immutable, so that just means that you can't change a string. You can change a string and return, like you can't change a string value and keep the same value. Like you can do x++ and it'll increment x, right? But you can't do that to a string. You can call a function to change the string, and then it will return a new string. So you have a brand new object. You don't have the same string object that you had before. And but string builder allows you to build a string up, so you can it makes it mutable is what we would say. So we're going to do numq.add, and then we're going to add x mod 10. And then we're going to do x is equal to x. We can just do the division 10. So x is equal to x divided by 10, and then that's it. That'll be it for that. Not if. We want to do while. Not if statement. This was my original solution, and after that I did while numq is empty, but is not empty, so we'll add the not operator in the front. While the cube is not empty, we'll have a string called num, and that we're going to set that equal to just a blank, and then we'll do num plus equals numq. So this holds our numbers, and we want to remove the first element, so that would be our 3 in the first example, and then we call the toString operator, and this will turn the number into a string. And then once we have our string, we can go ahead and set the solution. Well, there's a problem with this right now. So this works for 1 and 2, but it doesn't work for, or it works for 1 and 3. It doesn't work for 2. And the reason it doesn't work for 2 is because it's negative numbers right here. So the queue will store -3, -2, and -1, and then when we put it in the string, it just messes everything up. So what we want to do is we want to set x equal to x is equal to the math collection, or the math library, and then we're going to call the absolute value function and pass it to x. So x is going to be equal to the absolute value of x, so x will always be a positive number, and then when we do the mod operator, it will always give us positive numbers, and that's what we want. And the isNeg keeps up if it's negative or not. And at the end, we'll return a negative if it's negative and a positive if it's positive, right? And then from here, we need to use a try and catch block. The way try and catch blocks does is if you call a function that throws an exception is it's a problem that can happen inside your program, right? So it's our error handling, right? This is the Java's error handling. So I think it's called, let me see what the exception is called. The exception is called number format exception. So this will handle the case in which the number is bigger than the 32-bit solution, right? So if it's larger than the number we can store, we can return 0. And the function that returns the error is the parse integer function. So we're going to create an int solution, right? And then we want to call the integer dot parse int, and then you pass the parse integer a string, and then we're going to pass it our num, and that will grab the integer inside of it and store it as an integer. And then return is negative will return the solution if it's negative or positive, and then if not, it will return 0. And that's kind of my logic for this. I think I did everything correctly. No semicolons. Yeah. Okay, be sure to call your constructors. Go ahead and try this out. So you gotta call the new operator as well. I'm just fumbling completely on that aspect. We run this, it should work this time. Yeah, so it works for 1, 2, 3. They wanted 3, 2, 1. That's what we returned. And then negative 1, 2, 3, they want negative 3, 2, 1. And that's also what we returned. And then in case 3, if we want 1, 2, 0, we return 2, 0. And then we can go ahead and submit this. It's a slow solution because we didn't use the parse integer, but this is the logic I used. It runs at 4 milliseconds. It beats 3%. That's not many people it beats, but this is the solution I came up with, and it checks everything. And that's when I was looking at nits. I checked nits out for, I mean, he's done about every LeetCode problem, it seems like. And he also does it in multiple language. So I would check out his YouTube channel. He has great explanations. I've said this a few times. But he does it, he usually does Python and Java and JavaScript. Python for sure. If he doesn't have a Java or any other language, he does Python every single time. But he usually implements a nice Java solution. He also provides explanations, what to look out for, his approach, and if there's multiple solutions to the problem, he'll also show those. And I think that's also, yeah, see, here's the solution too. Yeah. Okay. Oh, wow. He's got some big functions. So reverse is equal to 0. So that's the value he wants to return. X is not equal to 0. Kind of like we were doing. And then integer digit is equal to X mod 10. So this is the error checking. So this right here is checking if it's in the range, the integer range, and if it's not, then it will if it's out of range, it'll return 0, and if not, it sets reversed equal to reverse times 10. So if you can imagine that we have 1, 2, 3, right? He does 1, 2, 3 mod 10 and stores it in digit. So digit is equal to 3, because we know anything times mod 10 just returns you the first digit value. And then he sets x equal to 1, 2, 3 divided by 10, which is equal to 12. And then reversed is equal to reverse times 10, reversed is 0, and then it adds the digits. So reversed is now equal to 3. And then for the next value, it does the loop again. It does 12. It'll do the 12 mod 10, and that will give you the digit 2. And then it sets x equal to that divided by 2. So x is equal to 12. So now it's equal to 1. And then 2 is equal to 2 is equal to all, like the reverse, times 10. So that would be 30 plus the 2. So you would store the value 32. And then the next go around, digit will be 1. You'll do 32 times 10, give me 320, and then you add the 1, you get 321. That's also a very nice solution. So he did this completely using math, like just the integer arithmetic, and I did mine creating a queue and then adding all that to the string. We could probably, yeah, we don't even have to do any of that. I wonder if we could shorten this up a little bit. We don't have to iterate it twice. We don't even need the queue. I was just thinking the queue so we could, the data structure is first in, first out. So, you know, whatever you add into it, you can take out. So we can do the x mod 10 dot to string. And then we can create our string num, set that equal to nothing. And then we can do num plus equals. So this does the same as our while loop, except we get rid of some memory that was taken up, and we don't do n squared twice. So if we go ahead and run this, this should be also a valid solution. Cannot be this dereferred. Oh, okay. So we probably have to store that into a temp variable. So we can do int temp, is equal to that, and then we can do num plus equals temp toString. Don't forget the semicolons. I'll try that one more time. It cannot be dereferenced. Now I am confusion. Dot toString num dot remove dot toString string num is equal to that. Num is plus equal temp dot toString call the constructor. It cannot be dereferenced. Okay, I'm not really sure what this error even means, so we're gonna do a little bit of professional deving and ask ChatGPT. This means you trying to call a method like toString on a primitive type int, which does not have methods. Only objects to be referenced. I.e., you can call the method. Exits fields on them. Here's what happened. Okay, yeah. So we need to make this an integer. This should work correctly. Yeah. And then if we run this, this should have a little bit of a faster runtime because it was an O of an N plus N. Yeah, so it's 3 milliseconds, it beats 4%. Adds a little bit of time. We instead of looping twice, we loop one time. This is actually the more valid solution. We just used the string, and we could probably just box this in. We don't even need the. Yeah, we'll just leave it as this. This will be my solution. And where is this error from? Oh, I don't even know what that means. It's a little red dot. Anyways, that's gonna be all for today's video. I hope y'all have a blessed day. I hope y'all stay healthy, and y'all can stay coding. And I will catch y'all in the next video. Hey Devs is out, and thank y'all for all the subscribers. Be sure to like and subscribe as well. If you have any suggestions or comments, be sure to leave them down below, and I'll see y'all next time.